This is a demonstration of the HLImage++ thresholding tool. The thresholding tool converts color and grayscale images into black and white binary images. One of its primary uses is creating masks for other tools to use. I'll demonstrate with the blob analysis tool. First, I'll use the blob analysis tool's built-in thresholding capabilities to find the crosshair on this image, and then I'll repeat the operation using the thresholding tool to give an example of when you might want to do it that way instead. We'll select our crosshair image as the input image and leave the mask image blank. To generate a mask, we'll use the blob analysis tool's auto thresholding feature, and we'll need to check invert output since the object we're looking for is a light object on a dark background rather than the normal dark object on a light background. With everything set up, we'll click Find Blobs, and then let's zoom in on the results. As you can see, we have one blob surrounding the entire crosshair and another one surrounding the black part inside the crosshair. Since in this case we don't want the child blob, we'll open the Blob Finding Options dialog and uncheck Grow Children. Then if we click Find Blobs again, only the outside blob is found. Often this method will give you the results you need, but for this example we'd like to get rid of the little jagged line here, so we need to use a masking method that allows us to smooth out the mask. So let's close the Blob Analysis tool and open the Thresholding tool. Once again, we select our image as the input image and leave the output image blank. We could set our thresholds manually by dragging these bars on our graph, and if the lighting of your images is well controlled, you may wish to choose that method. In this example, we'll choose auto thresholding, which enables the tool to automatically compensate for changes in lighting. Also, as we did in the Blob Analysis tool, we need to click Invert Output since we're looking for a light object on a dark background. Now we'll click Threshold to generate the binary image, and let's tile those and zoom in. And as you can see, we have an image with a black crosshair, white inside, and jagged edges just like we saw on the mask in the Blob Analysis tool. At this point, we're headed towards exactly the same results as we had using the Blob Analysis tool's built-in thresholding features. But since we've created our mask image separately, we can now use the binary morphology tool to smooth out those edges. We'll select the closing operation, set output, our mask image, as both the input and output images, and we'll set our number of iterations to 3 to ensure that we can close up this inside area. When we click Run, you'll see that the inside is filled in and the edge has been smoothed somewhat, but we want to smooth it out even more. So we'll increase our number of iterations to 5 and click Run again. As you can see, we now have a smoother edge. So we'll close the binary morphology tool and open the Blob Analysis tool again. We'll set the original image as our input image, but this time, instead of checking auto thresholding, we'll select Output, the binary image we've just created, as our mask image. When operating this way, it's important not to check manual thresholding or auto thresholding, because either one of those operations would overwrite our output image. It's also worth noting that since the closing operation filled in the white inside our crosshair, we no longer need to uncheck Grow Children in the Blob Options dialog. So we'll click Find Blobs, and now as you can see, we've found the crosshair with the smooth edge that we have in our mask image. This ability to fine-tune mask images is one of the advantages of using the thresholding tool rather than the built-in thresholding capabilities of some of the other tools. Another instance where you may opt to use the thresholding tool is when you'll be performing multiple operations using the same mask image. Using the thresholding tool rather than the built-in thresholding features enables the operation to run faster by performing the thresholding only once.